So we need to compare qualitatively low Earth orbit and geostationary orbits. So if we look at a planet, the Earth, you need to be above a certain height to avoid contact with the atmosphere. Any contact with the atmosphere, and it's not just a blanket edge, a boundary. The atmosphere extends way out and it gets thinner and thinner and thinner until there's hardly any gas particles there. If you're moving through any of those gas particles, you're going to experience friction, and this is the main cause for satellite or orbital decay. Where an orbit breaks down because the speed of the satellite can't be maintained and it comes in, crashes to Earth. So low Earth orbit is typically around 1,000 kilometers, 1,000 to 2,000 kilometers. Anything above about 200 to 250 kilometers. They have an orbital period of around between 1 and 2 hours. So every spy satellites tend to have a polar Earth orbit. So as they're rotating at this height and the Earth is spinning around underneath, they cover the whole Earth's surface, and they tend to be used for photography. Various countries, war photography, strategic photography, if you're going to call it that. Some of the Earth sensing. But that fact that they have a 90-minute or so orbit, because they're so low, they're covering a lot of the Earth's surface. Remote sensing is the word I was looking for. Studying the Earth's surface. Typically geostationary satellites have a much higher orbit. If they're orbiting over the equator or over the Earth much higher up, they have a period of approximately 24 hours. So it could be a little bit less, 23, 50 something, 55, 58. Typically much higher, around 36,000 to 42,000 kilometers. So they're way above any interference from the atmosphere. They're useful for communications because they stay over a country and follow that part of the Earth's surface as they move around. Also for weather patterns over a particular country. Our weather satellites are up over north of Australia and look down on the whole of Australia. The LEO can be used for looking at weather that's coming, so as the weather patterns are spreading or moving around the Earth, they can be used for that. Mapping areas that are beyond the country's control, the LEO might be good, and the low Earth orbit. They're qualitatively comparisons, so we're not trying to make quantitative comparisons. So in general knowledge, geostationary satellites will stay at the same position and move around with the Earth with the same period, and that's the main difference. How are they the same? They're both expensive, very expensive to get things into space. The low Earth orbits have a shorter orbital period, and they travel faster. They have an orbital velocity that's higher than the geostationary ones. The geostationary ones, their orbital period matches that of the Earth's surface.